Hello everyone and welcome back. In our previous lesson, we learned about strings. We discovered how Python stores text, how to access individual characters using indexing, how to slice strings, and how to use string methods to manipulate text. Today, we are going to learn about another incredible important data structure in Python, lists. So far in this course, we've stored one value inside one variable. For example, name is equal to Alice or age is equal to 20. This works perfectly fine when we only need to store a single piece of information. But what if we are creating a program for a school? Imagine we need to store the names of 30 students. Would we create variables like student 1 is equal to Alice, student 2 is equal to Bob, and so on and so forth, and continue until student 30? That would quickly become difficult to manage. The same problem happens in many real-world applications. Think about a shopping cart containing multiple products, a contact list in your phone, or student marks in a classroom. In all of these situations, we want to store multiple related values together. That's exactly what lists are designed for. By the end of this lesson, you'll know how to create lists, modify them, loop through them, use built-in list methods, understand tuples, and build useful programs like a shopping cart manager, a student marks manager. So let's begin. So let's first understand the problem lists solve. Suppose you're writing a program that stores 5 favorite fruits. Without lists, you might write fruit 1 is equal to apple, fruit 2 is equal to banana, fruit 3 is equal to orange, fruit 4 is equal to mango, and fruit 5 is equal to grapes. Now this works, but what if you have 100 fruits or 1,000 fruits or products? Managing hundreds of separate variables would be extremely difficult. Instead, Python lets us store all of them together in one variable, like the example on the right-hand side. Now, everything is organized inside one collection. Instead of remembering 5 variable names, we only need one. Lists make programs much cleaner and easier to read and easier to maintain. So what exactly is a list? A list is an ordered collection of multiple values stored inside square brackets. The syntax looks like the first example on the screen. Fruits equals to square brackets and the elements inside that you want to store. Notice that these brackets tell Python that we are creating a list. Each value inside the list is called an element or an item. In our example, apple is an element, banana is an element, etc. The elements are separated by commas. Think of a list as a shopping basket. The basket is the list. Each product inside the basket is an element. You can have as many elements as you like. Consider the following examples. The lists are very flexible. They can store numbers, they can store strings, and they can even store different data types together. Here we have a list which stores only string. We have a list which stores only integer, and we have a list that stores only Boolean values, and also another list which mixes things up. Python allows this. Although in larger programs we usually keep similar data together, it's useful to know that lists can contain different types of values. Now let's create several different kinds of lists. A list of colors, a list of numbers, and a list of decimal values, and an empty list. An empty list is simply a list that doesn't contain any element yet. Later on, we'll figure out how to add items to it. Printing a list is just like printing any other variable. So let's go ahead and open a VS Code. So I'm going to demonstrate to you now on how to print out a list. Printing a list is just like printing any other variables. Now let's see what the output comes out to be. And as you can see, Python displays every element inside the square brackets. Now comes one of the most important concepts. Just like strings, lists also use indexing. Let's create a list. Consider the following list. Python numbers each element starting from 0. Remember that the programming starts counting from 0, not 1. So let's access the first fruit. Now let's run the program and see what the output comes out to be. And the output is apple. Similarly, I can access the second fruit and the third fruit as well. Indexing works exactly the same way as it did with strings. Lists also support negative indexing. Instead of counting from the beginning, we can also count from the end. Notice that the last element is always a -1. For example, now let's run this, and as you can see, it has printed out the last element. Negative indexing is especially useful when you only care about the last few elements of a list. Unlike strings, lists are mutable. That means we can change their contents after they've been created. Let's see an example. Consider the example on my screen right now. The output comes out to be apple, mango, orange. Notice what happened. We replaced banana with mango, and the original list changed. This is one of the biggest differences between strings and lists. Strings cannot be modified directly, but lists can. Just like strings, lists also works with the length function. The function counts how many elements there are inside the list. Go ahead and try this example out for yourself. Notice that the len counts elements and not characters. This is an important difference from strings. Now let's combine everything we've learned into a small program. Go ahead and create a list of 5 fruits and write 3 print statements in which you are going to first print out the very first fruit and then the last fruit and also the length of the list. This simple program demonstrates creating a list, accessing elements, and using the negative indexing. In the previous part, we learned what lists are, how to create them, how indexing works, and how to modify existing elements. But imagine you're building a real-world application. Would the list always stay the same? Of course not. A shopping cart gains new products, a music playlist gets new songs, a teacher removes students from class list. This means we need to add, remove, rearrange, and manage items inside a list. Fortunately, Python gives us many built-in tools to do exactly that. These tools are called list methods. Today, we'll learn some of the most useful list methods that every Python programmer should know. Let's begin. Just like strings have methods such as upper and lower, lists also comes up with their own methods. These methods helps us perform common tasks without writing complicated code ourselves. The general syntax is list name dot method. Unlike many string methods, most list methods modify the original list directly. This is because the lists are mutable. Let's look at the most common methods. The first method we learn is the append method. It adds a new item to the end of the list. Let's try this out with an example. As you can see, I've created a list called fruits in which the elements I've stored are apple and banana. After which I'm using the method append to add orange to the last index. Now let's run the program and find out ourselves what the output comes out to be. And as you can see, orange was added to the end of the list. Every call to append adds one new item to the end of the list. This is one of the most frequently used list methods. Sometimes we don't want to add an item at the end. Instead, we want to place it at a specific position. For this, we use the method insert. The syntax is very simple. List.insert the index, the value. Now consider the following example. Here I've taken a list fruits in which I've stored the elements apple and banana. After which I'm calling the method insert, through which I'm giving it the index where I want my element, that is banana, to be added. Now let's go ahead and see the output. And as you can see, I've got the output apple, banana, orange. Python inserts banana at index 1 and shifts the rest elements to the right. Now let's learn how to remove items. The first method is remove. Unlike insert, remove doesn't use an index. Instead, it removes an item by its value. For example, if I were to call .remove bracket element's name, it will remove that element from the said list. Now let's try this out for ourselves. Now take a look at this program. I've taken another list in which I've stored 3 elements, but in the second line I'm calling the remove method to remove banana from the said list. Now let's see what the output is. And banana has been removed. Python searches for banana and then removes it. Now remember that the remove method removes the first matching value it finds. If the value isn't present, Python will raise an error. Another useful removal method is pop. Unlike remove, pop removes an item by its index. Take the example on the screen and try it out for yourselves. Provide it with an index and see if it removes the element from that said list. Suppose we have a list of numbers that isn't in order. For example, numbers is equal to 50, 10, 30, 20, 40. We can arrange them using numbers.sort. Sort arranges numbers in ascending orders. It also works with strings. Python will sort alphabetically by default. Now let's try this example out. Now as you can see, I've taken a list which has 3 elements inside of it, and they are not in order alphabetically. So let's run this program and see if the output, and yes, in the output, we have sorted them alphabetically. Sometimes we don't want the alphabetical order. We simply want the list to be reversed. For that, we use the reverse method. For example, if I've got a list, say numbers, I have to simply use numbers.reverse to actually reverse all the elements that were inside of it. Notice that reverse does not sort the list. It will simply flip the current order. So if you're expecting that it might arrange the elements into descending order rather than ascending, no, it will just simply flip whatever the current order was. And also finally, to remove everything from a list, we have to use the method clear. Cut.clear, and it will remove everything inside that list. But the list itself won't be deleted. The list will still exist, but with no elements. So far in this lesson, we've learned how to create lists, access the elements using indexes, modify list items, add and remove elements, and many other useful methods. Those are essential skills. But imagine you have a list containing 100 student names. Would you write print student bracket 0, print student brackets 1, and continue all the way to students 99? That would be repetitive, time consuming, and difficult to maintain. Instead, Python allows us to process every element in a list automatically using loops. We'll also learn how to store more complex information using nested lists, which are lists inside other lists. By the end of this section, you'll know how to display every item in a list, search for value. Let's begin. Suppose we have a list of fruits. We can print them out one by one by using print fruits 0, print fruits 1, print fruits 2. This works, but what happens when we have 500 fruits? Writing hundreds of print statements isn't practical. Instead, we can use a for loop. A loop repeats the same action for every item in the list. Think of it like a teacher calling attendance. Instead of remembering every student's name individually, this teacher will simply go through the class list one student at a time. That's exactly what a for loop does. So using a for loop with lists, and the basic syntax is for item in list name print the said item. As you can see with the example on the screen, let's try it out ourselves. As you can see on the screen, I've taken a list, fruits, inside of which I've stored different fruits, apple, banana, orange, mango, and after which I've written a for loop that is for fruit, that is for item in list, print out the item. So the output should be apple, banana, orange, and mango. Now let's run the program and see it out for ourselves. And as you can see, the output is exactly as we expected. Now let's understand what's happening. The loop starts with the first item, fruit, and becomes apple. Python prints it. Then fruit becomes banana. Python prints it. This continues until every element has been processed. Notice that we didn't need indexes. Python handled everything for us. This technique works with any type of list. For example, even there was a list of numbers, there was a list of Boolean values, or there was a list of mixed data types, it'll work exactly the same. Sometimes we want to know if a specific item exists inside a list. Python provides the in operator for this. For example, take a list with the elements like apple, banana, orange, and if banana in fruit, we will print out found. Now go ahead and try this program out yourself. The in operator returns either true or false. This is useful in many situations. For example, checking if a username already exists, verifying whether a product is available, searching for a student's name, or, well, finding a song in a playlist. So far, each list has stored simple values. For example, students is equal to Alice, Bob, Charlie. But what if we want to store each student's marks along with them? We could create two separate lists. This works, but it can become difficult to keep both of them synchronized. organized. So a better solution is nested lists. A nested list is simply a list that contains other lists. Take the example on the screen. Each inner list stores the information about one student. Think of it like a table, the name and the marks. Each row is its own list, and the entire table is one larger list. Take the example on my screen. Suppose we want Alice's marks, so we write print students 0, 1. Then the output is 90. Now let's understand this. The student 0 returns Alice, 90. Then 1 accesses the second element inside of that inner list, and the result is 90. Nested indexing may seem unusual at first, but it's simply indexing twice. We can also use loops with nested lists. Now let's try this out with the example. As you can see, I've got a list students inside which I've got more lists, that is Alice, 90, Bob, 85, and Charlie, 78, each representing information about one student. Now let's run this program and see what the output is. And as you can see, we got the output Alice, 90, Bob, 85, and all. Each iteration gives us one complete inner list. Now let's build a simple student marks manager and print out the results neatly. As you can see, I've got a list of students along with their marks, and I've written a for loop in which I'm printing each student's name first, followed by a colon, followed by their marks. Let's see if, and there we go. Now take a look at the screen. This is the same example we've just discussed, but I will encourage you to make one small adjustment to it. I want you to add in a feature which calculates the average for all students in the class using a for loop. So far, we've spent a lot of time working with lists, and lists are incredibly useful because they can change as your program runs, but not every collection of data should be changeable. Think about these examples: the days of the week, the months of the year, GPS coordinates, RGB color values, the mathematical value of pi. These values usually stay the same. It wouldn't make sense for the program to accidentally change Monday into some other day. For situations like these, Python gives us another collection type called tuple. Let's understand what tuples are and when we should use them. A tuple is an ordered collection of items just like a list. However, there is one very important difference. A tuple is immutable. That means once it has been created, its contents cannot be changed. The syntax looks very similar to the lists, but instead of using square brackets, we use simple parentheses. Now let's create a few tuples. Take a look at the example. It's just the same as lists, but we've replaced the square braces with the simple parentheses. Just like lists, tuples can also store strings, numbers, booleans, and all the other mixed data types. Even though tuples cannot be modified, we can still read their values through indexing. Indexing works exactly like it does for the list. So today it's up to you to run these examples. Go ahead and try this out for yourself and see if they are any different from the list. Similarly, negative indexing also works. We can also use the length function. So tuples support many of the same operations as lists, except they're modifying their contents. So you might be wondering what would happen if one modifies a tuple's contents. Well, Python will display an error. Why? Because tuples are immutable. Once created, they cannot be changed. Similarly, methods like append, remove, pop will not work on tuples and will give a Python error. Those methods belong only to lists. This immutability makes tuples safer when you want to protect your important data from accidental changes. Now let's learn a very useful feature called tuple packing. Packing simply means placing multiple values into a tuple. Consider the following example. Here, 3 values have been packed into one tuple, and this is how you're supposed to pack a tuple. But Python even allows us to write this. As you can notice, there are no parentheses anymore. If we were to go ahead and create and run this program, Python will automatically create the tuple for us. This is called tuple packing. Similar to tuple packing, there's another concept called tuple unpacking. If you can pack values together, can we separate them again? Absolutely. This is called tuple unpacking. Take the following example. Here I've taken a tuple person and put in the elements Alice and 20, after which I've defined two variables name, age, and I've assigned them to person. Now let's run the program and see what happens. And as you can see, the output is Alice and 20. Python will automatically assign the first value to name and the second value to age. Tuple unpacking makes code cleaner and easier to read. Now let's compare both the lists and values. So a question always comes to mind that which one should I use? Use a list when the data will change and use a tuple when the data should stay the same. It's up to the specific requirements of your program. Now let's review what we've learned. Today we've learned what a tuple is, how tuples differ from lists, how to create tuples, how indexing works with tuples, and why they are immutable, what packing is and unpacking is, and when to use lists and when to use tuples. You now understand both of Python's basic collection types and know when each one is the better choice. Thank you for watching, and I hope I see you next time.